So this is 2025 paper 1 question 6, and we're given this expression here, and we're told to write out the first three terms of the binomial expansion in descending powers of p. So you don't really have to understand that too much. If you go to page 20 of the Formulae and Tables booklet, you'll see the binomial theorem here, and there's a very good reason for why this works, but this is just a solution video, so I won't go into that. But you can basically kind of just fill into the formula. So you can see in the formula we have x plus y to the power of n. So in our example, the first thing in the bracket x is going to be 2p. Our y is going to be 3, and n, which is the power, is going to be 7. And then we can just kind of fill in. So if you're comfortable with summation notation, you can use this part of it here, or if not, you can just kind of use this part and follow the pattern, which is what I'll do here for simplicity. So we're going to have 2p plus 3 to the power of 7. That'll be equal to, and then the first thing we're going to have is n choose 0. So we're going to have 7 choose 0, because our power is 7. Then we're going to have x to the n. Remember, x in our case is 2p. And that's going to be the power of n, which is 7. And don't forget to put the power of 7 on the entire 2p. Then we'll plus n choose 1. And again, sorry, n is 7. Choose 1. And then we're going to have 2p to the power of n minus 1, which is 6. And then times y. And our y is 3, remember. And then we're going to have 7. Choose 2. And then we're going to have x, which is 2p to the power of n minus 2. 7 minus 2 is 5 times 3 squared. And then we can just say plus dot dot dot. We don't actually care about the rest of the terms. They are there if this is a perfect equality, but we only care about the first three. And as you can see, these will indeed be in descending powers of p, because this one is p to the power of 7, p to the power of 6, and so on. If not, you just kind of have to do it backwards, but in this case it works out. So we can kind of just put this in your calculator. So 7 choose 0 is equal to 1. And then when you're doing this here, don't forget to do the power of 7 onto both of the things in the bracket, multiply together. So the law of indices says that it'll be 2 to the 7, p to the 7, and 2 to the 7 is 128, and then we'll have p to the 7. Plus, and then 7 choose 1 is 7 if you put it into your calculator. Again, don't forget to put the power of 6 on both the 2 and the p. So 2 to the power of 6 will be 64, and then we'll have p to the power of 6, and that's multiplied by 3. And then 7 choose 2 is going to be 21. And then 2p to the power of 5, that'll be 32 times p to the 5, and then 3 squared is 9 plus dot dot dot, and then you can just put those into your calculator. So we'll get 128 p to the 7 plus 1344 p to the 6, and then plus 6048 p to the 5, and then plus dot dot dot, but we don't care about the rest. All we care about is the first three terms, and indeed they are in descending powers of p, so we're done. So next we're given a function h, and we're told that the equation h of x equals 0 has one solution. You show that r is equal to 9m. That seems really confusing, but remember that if this thing's equal to 0, that's just a quadratic. So you can just use the quadratic formula. X will be minus b plus or minus the square root of b squared minus 4ac all over 2a. Now if this has exactly one solution, what that means is that, see this part here? This is going to be equal to 0. Because obviously you can see we have plus or minus. So if this was anything other than 0, then we'd have one answer as plus that number and another answer as minus that number. That's two answers. But if this big square root thing is equal to 0, well then it's plus or minus 0, plus 0 minus 0. It's the same thing. There's only one answer for x. So in class you might have learned that one solution means b squared minus 4ac equals 0. And that's just me explaining why that's the case. And then we can just sub in. So our value for b, as you can see, will be minus 4 or, the number in front of the x. The number, I should have done a first, but a will be 6m, the number in front of x squared. And then the constant term will just be 54m, which is the thing that has no x beside it. So now we can just fill into this equation and solve. So b squared we'll have minus 4r, the whole thing squared, minus 4 multiplied by a, which is 6m, multiplied by c, which is 54m. So 4 or, and that's equal to 0, sorry. So minus 4 or, the whole thing squared. So we have minus 4 or, the easy way to think about this if you're not sure, times minus 4 or, and then we have minus 4 times minus 4, and then or times or. So that'll give us 16 or squared, because we're multiplying minuses together as well. And then you can multiply all those numbers together. And what you'll get is you get minus 1296m squared when you multiply all those together. And that's equal to 0. And now we can just solve for or. So we can say that 16 or squared will be equal to 1296m squared. Then if you divide both sides by 16, you'll get or squared equals 81m squared. And then if you take the square root on both sides, so if you take the square root of this and the square root of this, again, don't forget the laws of indices, that if you have the square root of two things multiplied together, that's kind of the same as the power of a half, so the same rules of indices apply. So we'll have 81 to the half times m squared to the half. Or again, you can think about that as the square root of 81 times the square root of m squared. So you have to do the square root on both of them separately when they're multiplied together. So then we're going to get r equals, and then what we're going to get is we're going to get 9m when we do those square roots, because square root of 81 is 9, square root of m squared is m. And then we're going to have plus or minus, because when we square something, it could be positive or negative. Well, regardless if it's positive or negative, you'll still get a positive, so it could be plus or minus. But we're told that m and r are positive constants, so in reality, we only have to care about the positive solution. So you can say that r and m are positive, so you can say they're greater than 0. Therefore, r is equal to 9m, and that is what they asked us to prove. Then it says use the fact that r is equal to 9m to find the value of this solution. I think the most straightforward way to do this is you have the original equation, right? Is this thing equal to 0? We can just replace that r with 9m. So what we can say is 6m x squared. Then we'll have minus 4 times 9m. Sorry, there should be an x there. X, that's just from the question, by the way, that x. I just forgot to write it in. Plus 54m equals 0. And you can see that all of these terms have an m in them, so we can just divide everything in this equation by m. And what we'll get is we'll get 6x squared. And then 4 times 9 is going to be minus 36x. And then we have plus 54 equals 0. You could solve this as it is, or you could divide across by 6, make things a little bit easier. And what you'll get is you'll get x squared minus 6x plus 9 equals 0. And then we can just solve this. So the factors of 9, we have minus 3 and minus 3, and they add to give us minus 6. So that's good. So we'll have x minus 3 times x minus 3 equals 0. Or in other words, x minus 3 is equal to 0 in both cases, no matter what, which means that x is always equal to 3. And this makes sense because we only have one solution, which is x equals 3. And then you can sub that back in again to make sure that you did it right into this equation here. And you'll see indeed that x is 3.